And I hope you enjoy. Cindy, I turn it over to you.
Great, thank you very much, Katie. And welcome to joining us from the United States, and good afternoon and good evening to others who are joining in from other parts of the world. My name is Cindy Vestergaard. I'm the director of the Nuclear Safeguards Program at the Stimson Center. It's a pleasure to welcome you all. A little bit on the Nuclear Safeguards Program at the Stimson Center. We are studying the resiliency of the verification system that underpins the nuclear nonproliferation regime. We work with governments, industry, and multilateral organizations to understand not only how evolving safeguards obligations are having an impact on states and industry, but also emerging nuclear facilities such as deep geological repositories and emerging technology are also having an impact. The Safeguards program has a project called Back End to the Future, where we're looking at safeguards related to deep geological repositories, whether national or multinational. And it is a pleasure today to be able to introduce Dr. Brett Leslie, who is from the U.S. Nuclear Waste Technical Review Board, NWTRB, in case you hear that acronym a number of times throughout the session today. Brett has been with the NWTRB since 2013. He has a long history with nuclear waste, including his doctoral research of repositories and conducted field and lab studies with radioactive materials, probabilistic risk assessments, and public outreach on U.S. spent fuel and high-level waste disposal program. So I'm going to turn it over to you, Brett. And just for all our participants to know, we will have a break during his presentation for Q&A, and then, of course, again at the end. And as Katie had mentioned, please direct your questions to Trin. And it's a great pleasure to have Trin join us as well. So we've got a great safeguards team. And Brett, over to you to tell us about the NWTRB's recent report on the critical role of underground research laboratories.
Thank you very much, Cindy. I'm assuming everyone can hear me fine. I've unmuted myself and away I go. Today, I will be talking about the critical role of underground research laboratories in disposal-related programs. And let me move to the next slide. And as Cindy just mentioned, it will be a two-part presentation. In the first part, I will describe and discuss a recent report in January that was released by the board on the role of underground research laboratories in DOE's ongoing geologic disposal research and development program. And we'll break and have some questions on that. And then in the second part, I'll talk about how some of the concepts I raised in the first part can be applied to national repository programs. And I will go into that, but that is not a board part. It's my own personal analysis once the board report has been released. But before I jump into that, and you'll see on the right is the cover of the board's report. But before I launch into part one, let me provide a bit of background on some key concepts on geologic disposal of spent nuclear fuel and solid high-level radioactive waste and national repository programs. The international consensus best long-term option for managing spent nuclear fuel and solid high-level radioactive waste is permanent disposal in deep underground repositories with the depth of the repository on the order of hundreds of meters or more. A repository is both a scientific and engineering project because both engineered barriers and the natural setting are used to limit release of the disposed waste once the repository is closed. The disposal concept and the engineered barriers are different for different types of rock and may vary between countries depending on the size of the waste package that will be disposed of. An important concept is how long will a national program for geologic disposal take? The quick answer is over 100 years. A national program for geologic disposal goes through various phases with key decisions before the repository is closed. The first phase is choosing a site for the repository, and most countries use these disposal concepts that incorporate specific engineered barriers as part of the siting process. As the board's 2015 siting report noted, no country has passed through the siting phase to the next phase of submitting a license application for repository construction in less than 30 years. The board's siting report also emphasized that both social and technical aspects factor into the siting process. Based on current experience, regulatory review and approval of a license application for repository construction can take several years, up to a decade or more. Once approved, construction can take another decade before a decision on operation is made. The operational period for most repositories is expected to last 50 to 100 years. Once the repository is closed, safety, as defined by each country's law and regulation, must be demonstrated by, among other things, projecting the performance of the geologic repository for 10,000 years or even more, up to 1,000,000 years. Another thing, the spatial scale of a repository is large. It's on the order of a square kilometer or more. Thus, as you will hear, underground research laboratories are at an intermediate spatial scale between surface-based labs like those found in universities and that of a repository. And experiments in underground research labs can last decades as compared to the shorter laboratory experiments. So now let's launch into the first part. I want to provide some context about the board and why we issued a report. Then I'll go into and describe a 2019 workshop that we had, focusing on some key points that the participants from the other countries provided. As those key points are also important in the second part of the presentation today. I'll describe DOE's research and development program. I'll briefly touch upon how the board conducted its review, and then I'll spend the latter part of the first part talking about the board's principal findings and recommendations. So about the board. In 1987, when Congress redirected the nuclear waste program to focus on Yucca Mountain, it also established the Nuclear Waste Technical Review Board as an independent agency in Title V of the NWPA amendments. The board is to evaluate the technical and scientific validity of DOE's activities relating to implementing the Nuclear Waste Policy Act. We're not a policy-related organization. We're focused on the technical and scientific validity. The Act identifies some of the activities that Congress expected the board to follow, which includes packaging of spent nuclear fuel and high-level radioactive waste and transportation. Those things are identified in the figures at the bottom, and also site characterization, design, and development of facilities for disposing of the waste. About the board, we're small. The board members, and I'm not a board member, I'm one of the permanent full-time staff, but the board members are really experts in their field. They are presidential appointees, but they serve part-time and staggered terms, and they serve until they're replaced. So under the law, we're required to report our findings, conclusions, and recommendations to the US Congress and the Secretary of Energy, and that's why the report title has that in there. To get a sharper point on that, if you look at the legislative history to the Nuclear Waste Policy Act, Congress identified what our purpose was. In fact, I'll quote it. "The purpose of the board is to provide a source of independent expert advice to DOE and Congress on technical issues and to review DOE's efforts to implement the nuclear waste program. The board has no authority to require the department to implement its recommendations, but it is assumed that the department will heed those views or clearly state its reasons for disagreeing." How we conduct our work? Well, we hold public meetings several times a year in different locations. These meetings are webcasts. We provide our comments usually either in letters after a meeting or in a report like we did this time. We make all of our information available on the public website. And here is the listing of the current board members. And if you want to know about their background, you can go to our website and look at short bios for them. So let's move on to the meat of the presentation, which is talking about the board's review activities. In April 2019, we held a two-day workshop that focused on underground research labs, DOE's disposal R&D program, and DOE's international collaboration in other countries' underground research labs. We invited 3 speakers from countries with operating underground research labs. These are countries that are also fairly advanced in their repository program. And we invited one from the United Kingdom because they're at a point where they're conducting generic R&D studies, just like the Department of Energy is doing. And so they described their program and described how they are integrating and the contribution of the Underground Research Laboratory and how it plays into their program overall. And I think one of the main conclusions is that each of the speakers emphasized that these underground research labs play a critical role in their programs, not just technically, but from a social aspect. And I'll give you a couple quick things. In Sweden, their underground research laboratory is in the top 20 for tourist destinations. And as the member from France indicated, they could not be where they are explaining in the public debates their concept of disposal without an underground research lab. So now the two key points that I want to touch upon is using underground research lab improves technology readiness. And I'll spend some time on this figure here. This figure is the NASA thermometer. It was developed in the 70s and defined in 1989. But basically, to the left are the different types of activities one conducts as you're developing a program, from basic technology through technology development, from testing to launching and operations. And some nuclear waste programs have used this as a way to assess where they are. It's important to understand before you operate a repository, you need to get to the top of the thermometer. Patrick Wittrin from the implementer in Sweden indicated that using their URLs, they went from someplace down near here all the way up to here by the time they submitted their license application. So again, one other aspect that he pointed out is this scale is used extensively in research program, and often the expected level to be achieved is defined in the project. The second main topic that I'll touch upon in the second part of the presentation, and what was a very important part to the board's report, is the idea of a safety case. And let me provide you a definition, the definition that the board used in its report. A safety case is a collection of logic and evidence that demonstrates that nuclear waste repository meets the performance required defined by the appropriate regulatory authority. A safety case includes key results from the safety assessment, which is a quantitative analysis of the overall system performance, where the performance measure is a radiological impact or some other global measure of the impact on safety, both during operations and after repository closure. The safety case includes quantitative and qualitative supporting evidence and reasoning on the robustness and reliability of the repository, its design, and rationale for the design choices made, and finally, the quality and uncertainties of the safety assessment and the underlying assessment. Irina Goss from NAGRA, the Swiss implementer, had a wonderful diagram that the board included in its report, but underground research labs basically bridge the spatial and temporal scales from the laboratory to the repository, but they provide a primary focus for evolving this safety case over time. And I think one thing that I do want to bring in is one of my colleagues at EPA described the safety case as a process more than a product. And so both Sweden, France, and Switzerland talked about how underground research labs go from these experiments. You do a phased approach, you learn, you change, you figure out what you don't know, and then you move to the next phase. So let's move to the DOE's disposal R&D program. In 2010, when DOE began generic research on alternative host rocks, these environments were very different from that at Yucca Mountain. And since 2010, DOE's activities has focused on the post-closure safety, i.e. the safety after the repository is closed. On the right is DOE's program, their disposal research program. 3 types of rocks: argillite or clay, crystalline, like in Sweden and Finland, and salt, which is being contemplated in Germany, also the UK. And there is an existing repository, but not for high-level waste and spent nuclear fuel. That's the WIP repository in New Mexico, which has a different type of waste, which is transuranic waste. DOE is developing their safety assessment toolbox, which is the Geologic Disposal Safety Assessment. The focus of our meeting was really on the international disposal R&D and those collaborations in the underground research laboratories. And one area of focus that DOE is looking at right now is the direct disposal of dual purpose canisters. This is important because right now the canisters that contain the commercial spent fuel at various reactor sites are designed for storage and transportation, and they weren't necessarily designed for directly disposing them in underground repositories. And we'll get back to this in a little bit later in a following slide, but the size of a package generally is a strong indicator of how hot the repository may be. The DOE prioritized its R&D activities initially in 2012 and just recently updated their priorities in 2019. And they used two metrics to judge where their program of R&D was at: the state of art level. In other words, were they trailing other countries in particular types of calculations or understanding? And also this importance to safety case were used. And again, I'll talk a little bit more about the safety case later. So what's important to note is DOE since 2012 has been doing these underground research laboratory collaborations both in Europe and Asia. DOE identified that it's been extremely beneficial, and the board agreed with this point, that it really has provided access to data and decades of experience in different type of disposal environments than DOE had previously considered in a cost-effective manner, and basically allowed DOE to get up to speed very quickly. Those efforts since 2012 have really helped DOE develop its safety assessment framework, advanced DOE's repository system analyses, and also advanced DOE's uncertainty quantification and sensitivity analysis methods. So this is a busy diagram, and I'll spend some time going through it. But basically, DOE has organized its underground research R&D activities or its R&D activities in certain priority topics. And they're depicted in this diagram by rock type and location within the repository. But the four main areas are this near field perturbation. When I talked a little bit earlier about temperature, a repository perturbs the geology by two main factors. One, when you dig a tunnel, you change the state of stress in the mechanical behavior of the rock. And two, when you emplace the waste, it creates a heat source in the rock. And that heat causes changes in the mechanical behavior, the hydrologic behavior, the chemical behavior, and I think there's one other, but the thermal behavior of the entire rock. So understanding how that added heat changes the near field, and the near field being the area close to where the waste would be in place, is a critical aspect of all geologic repository programs. DOE has also focused on engineered barrier integrity, and these are also color-coded in this diagram, flow and radionuclide transport in the gray. And what you'll see are in this diagram around each of these named either facilities or actual experiments are the flags of the countries where DOE is contributing. There's a lot in crystalline rock. That's because a lot of countries have crystalline rock, including Sweden and Finland, the Czech Republic, Korea. A few less in the argillite and mudstone, primarily France and Switzerland, and then even less in the salt, the German, and as I said earlier, the WIP facility in New Mexico is actually home to one of the generic R&D experiments that DOE is running right now. So our review and report, we basically, again, our focus, consistent with our mandate, is to review the technical and scientific validity of DOE's activities. We used the workshop and a previous fact-finding meeting with DOE, reports published by DOE and others, and the information from that fact-finding meeting is also on our website associated with this, with the report itself. The report has findings and recommendations sprinkled through several of the chapters, which we called specific findings and recommendations. And then we had 4 principal findings and recommendations, and that's what I'll spend the next couple of slides talking about. So our first finding was that DOE's participation in these URL-related international research efforts greatly benefits the U.S. Geologic Disposal Program. We also noted in this finding that the DOE's efforts are also helping the other countries, which the presenters freely noted during their presentations. Based upon this finding and the record before it, the board recommended that DOE should expand its collaborative efforts and enhance its capacity for R&D and geologic repository, but kind of expand that capacity to address the technical needs for design, licensing, construction, and operation for US waste types, including those large dual purpose canisters. Other underground research labs, other countries are benefiting from similar underground research, like from energy companies that are interested in either carbon sequestration or fracking. And so the boards thought it would be worthwhile for, again, DOE to focus on other underground opportunities that are not just radioactive waste related, and to compile best practices and lessons learned from each of the countries that it has been participating with, so that as it moves forward, it can parlay some of those best practices forward. And on the right is an example of the kind of demonstration of technology that the board was thinking of. This is a brand new facility being designed by France, which will demonstrate the mode of transportation from the surface to underground, which is a funicular, sorry. And it's a full-sized 12% grade. It's 100 meters long, and it will be open to the public once it's operating. So the second finding, principal finding that the board had is the other countries use the underground research labs to explain the technical basis underlying their safety cases, periodically reassess their gaps in knowledge, and define those new activities. Remember that circular diagram where you go around and iteratively figure out what you need to do. And that these other countries demonstrate that the technology that will allow the implementation of the proposed safety concept. On the right is an example of the Sweden's canister retrieval program. Again, this is done with non-radioactive waste, so people can come in and visit the location of the actual test. The board recommended that DOE make systematic use of these R&D results to regularly update generic repository safety cases that can be easily understood by and demonstrated to the public. Again, the demonstration is the one thing that the board really hit on in this report. And those demonstrations should be relative to the safety case that are relevant to direct disposal dual purpose canister in the 3 different types of host rock that they're currently conducting their work in. And to DOE's credit, DOE has already started a plan test at the Grimsel test site called Hot Bent that is focused on the dual purpose canisters that are larger and hotter than other countries' disposal packages. And what will happen is this is bentonite, a clay mineral. With the larger packages, the temperatures will be much higher than the limits that other countries have set of 100 degrees C. It's thought that if dual purpose canisters are disposed in repositories that use bentonite, that the temperature might be 150 to 200 degrees C. And frankly, the scientists and the nuclear waste experts don't have a clear understanding of the impact of those temperatures on how the bentonite barrier may behave in the future. The third principal finding that the board made is DOE needs domestic URLs to advance geologic disposal over the next decades. It's all fine and good to be overseas, but it's hard to develop the whole number of people with all the different skill sets if they have to go overseas. And so the board said it's really important to have domestic underground research labs in the US so that we can train people next generation. I'm aging out of the generation that was associated with Yucca Mountain. And as I said earlier, repository programs will last 100 years. Jacques Delay from Andhra, the implementer, had a nice presentation just last month. And his final conclusion is put on the right as a picture of their underground research lab. In addition to the technology, it's about maintaining those skills and experience of the long time needed for those disposal projects. So the board recommended that DOE should pursue 1 or more domestic underground research labs to advance the development and demonstration of disposal concept and provide the platform for training next generation of workers. And the board went on to say that DOE should evaluate what underground sites in the US with existing infrastructure could be used as generic underground research labs. And an example is The Grimsel test site is built off an underground highway pass in the middle of the Alps. That's using existing infrastructure. If DOE expands its domestic URL program in this way, the board said DOE should consider broadening its focus to include developing and demonstrating construction and operational concept for disposal, larger, more formal training opportunities. In fact, Switzerland now has a repository training school associated with, I think it's the Monterey Underground Research Lab test site, and also broadening accessibility of the domestic URLs to researchers and universities and to international collaborators, i.e. modeling on how the collaborations internationally have helped all parties move forward quickly. The last principal finding that the board had is on that is a little more technical in the sense that we are a technical and scientific board. We reviewed the detailed science and experiments that they were doing, and we agreed that or we found that international collaborations have really advanced DOE's generic disposal R&D program, but further work on those coupled thermal, hydro, mechanical, chemical models and both underground and laboratory-based research can strengthen its program. And again, remember from the very beginning in the cover of the report, you go from laboratories to underground research labs, and then the next scale is to repositories. So there's this integration between the laboratory and underground research labs. You don't just do one, and you do both, and you use them iteratively. The board's recommendation is that the DOE should continue advancing its thermal, hydro, mechanical, chemical-based research and model development, pursue more underground research lab and laboratory-based studies, particularly at the elevated temperatures expected for those dual-purpose canisters. In doing so, DOE should consider designing and conducting their activities to test hypotheses and assumptions. And this is a really critical factor because DOEs, if they use those larger and hotter packages, there are assumptions that other countries have not yet tested. And so it will be important to really focus on test hypothesis and assumptions, employ that iterative approach with the circular diagram. In a particular area, include the geomechanical and thermal effects and flow and rate transport models. And finally, use the results from the WIP facility where they're doing generic testing to focus on the models of salt behavior embedded salts. So let me summarize the first part. I hope I've provided sufficient background on the board and why and what it does for its work to understand that the board was required to report to Congress and Secretary on DOE's activities. And the board recommended that DOE should expand its collaborative international UR activities, systematically use those results to regularly update generic repository safety cases relevant to the direct disposal of dual-purpose canisters in different host rocks, pursue one or more domestic URLs to advance the development and demonstration of disposal concepts, and continue advancing its coupled processes, research and model development, and pursue more URL and lab-based studies, particularly at elevated temperatures. And with that, I will turn it over to Trin to start the Q&A. And let me release my screen.
Thank you, Brett, for a good presentation for the first part. And thank you everyone to be being here today. So we will stop for about 10 minutes for the Q&A section. So we will address the question in the Q&A box, or you can raise your hand using raise my hand feature, and we will address the question in the order we receive them. So I have one question from the audience. So Tom Countryman asked, does DOE have any cooperation with Russia and China in this field?
It's a good question. I don't think anything in Russia. DOE has a comprehensive report on their international collaborations every year. I know they've done some amount of work in China, and they have hosted staff from the implementer, I think, at the national labs. So there is some collaboration. I don't know to what extent, but it would be in that, that reference is cited in our report, and that's a great place to figure out what DOE is doing everywhere.
So if anyone have a question, feel free to, raise your hand so that I can let you pose the question directly. So another question coming from the audience, Caroline Cowboy, I have a question about, is recycling of spent nuclear fuel part of the discussion?
Not in this presentation. And basically we follow what DOE is doing, and again, our mandate is under the Nuclear Waste Policy Act and the DOE activities therein. So.
Okay, thank you. So another question coming from the audience, Mark Hoyt asks, did the underground work at Yucca Mountain include the type of work that would be done at the URL?
So that's an excellent question, Mark, and I'm going to address that directly in the second part of the talk, so I don't want to spoil it. Sorry, you'll have to wait.
Right. So Hariong Jung asks, do you have timeline to develop a generic URL?
So I'll also, Harry, that's a very good question. Nice to hear you on the webinar today. I will address that also in the second part of the presentation. So I don't want to really steal my thunder without showing you the good visual.
Right. Thank you, Brad. Okay, so thank you everyone for continue posting your questions. So we're coming to the next one. So Daniel Medley asks, what does the report assume about the U.S. nuclear waste program?
Good question, Dan. Dan's a former colleague of mine at the board. The board did not make any assumption on what the direction will be regarding nuclear waste policy, but was really focused on what DOE is doing now, which Congress has funded them to continue to do generic repository R&D. And so that's really what the focus was on. And I think Dan might want to bring that question up again, because I think I'll address it a little bit in the second part, but if I haven't done well enough, I know Dan will bug me.
Another question coming from Sven Bader. What kind of geology would the NWTRB recommend the DOE place it into recommended URL?
I don't think the board will ever make a recommendation in terms of either a site or a URL. It's, that's a decision that's left up to DOE. The DOE is the implementer. They're responsible for coming up with the design. The US is both blessed and cursed by having multiple types of rocks. Countries like Sweden and Finland only have one type of rock, and therefore an underground research lab is only going to be in crystalline rock. On the other hand, the recently passed German legislation requires an underground research lab in each type of rock. And so they expect that they'll have to have an underground research lab in salt, crystalline rock, and sedimentary or argillite rock. In the US, there is nothing in the policy, in Nuclear Waste Policy Act, and nothing that Congress has directed through appropriations that would guide DOE in any directions in terms of how many or what type of rock.
Thank you, Brad. So Alfredo Labe asking, have you considered the variable of public support for this kind of facility? Argentina tried to implement a repository in the south of the country some years ago, only to encounter a fierce opposition. The project had to be postponed.
Yes, and I am going to definitely touch upon this a little bit more in the second half, but the answer is that each of the countries that presented to us talked about the importance of either their domestic underground research labs in early on, before they even cite a repository, just to allow people to explore what is the underground of the earth like. Most people don't have a very clear concept. And I'll give you another example. Canada right now they're developing their engineering and their disposal concept above ground and demonstrating it at their Oakdale facility. They don't have an underground research lab, but they're demonstrating the technology. And so that's part of how Canada is attempting to bring in the knowledge so that the citizens can be informed in terms of the development of a repository program.
Yeah, thank you, Brad. Mark Hoy have another question. Can part of WIP be used as a URL?
Yes. In fact, right now, and the report says a little bit more than I stated in the recommendation. It was DOE should evaluate existing places, and we talked about how WIP is being used in one part, but we recognize, the board recognizes that WIP is an operating disposal facility, and we don't want to impact that really critical national need. And so we encourage DOE to think about how more activity could occur at WIP, but where the board was extremely mindful of what the primary mission of the WIP facility is.
Okay. So we have Daryl Wolford from the National Defense University. And the question is, does your report address any nuclear material safety implication?
No, it does not. And I'll talk a little bit about safeguards in the second part of the talk, but it didn't look at the safety of the waste wherever it is. I would point out that the waste is regulated in the U.S. The commercial waste is regulated, and the safety is confirmed by the Nuclear Regulatory Commission. We don't have a safety mission.
So another question coming from Mark Goodman. Did the committee consider any issue other than safety, such as monitoring or verification?
So the monitoring and verification, the verification part I understand goes to safeguards. Monitoring, yes, we held a public meeting, had a report on monitoring as it's considered for safety. I'm going to say back in 2018 in the spring, we had a report come out on that. And we picked up that topic again, I think in chapters 5 or 6 of this current report on the type of monitoring, performance monitoring of the various geologic and engineering, for instance, corrosion of the waste package or the temperature evolution and re-wetting of the bentonite barrier, but not in terms of the monitoring and verification framework considered for safeguards.
Okay, so probably at that time, we will take like 3 more questions from the audience, and then I'll let Brad continue with his presentation. The rest of the question will be addressed at the end of the presentation. So Bob Holstead asking, please discuss finding of the Canadian URL at Pinawa for granite disposal in the US.
I'm sorry, could you repeat that, Trent? I'm not sure I understood it.
Yeah, please discuss finding of the Canadian URL at Pinawa for granite disposal in the US.
Yeah, that predates my knowledge. I do know a little bit about it, but I mainly know about it being decommissioned. So I can't comment on the siting, but that's something I can consider as I move forward.
Okay. So Charles McCombie asks, should DOE go for a generic or potentially site-specific URL?
Well, as I will state in the second part of the talk, all implementers are guided and really can only do what the law tells them to do. Each country has a national law that guides this repository program, and the US is kind of in a funny situation, not a funny situation, but a situation in which the policy, we have an existing policy. There's been a hiatus in terms of implementing that policy. During that break in time of implementation, DOE is conducting research and development. And so they have no authority to cite, do a site-specific underground research lab that could be associated with another site for a repository.
Okay. And one question before we move on to the second part. Jim Werner asks, does the NWTRB draw any lesson from the proposed whip test phase examined by the NAS in 1992 and canceled by DOE in 1993 with regard to clear goal for testing that can only be done in an URL?
No, and Jim, thanks for that question. We did not, the board, as part of its review, the board did not look back at the WIP program for any lessons learned there. Again, we were focused primarily on current activities because our mandate is to continue an ongoing review. I suppose if that kind of thought goes into any change in the policy, that might be something that the board would look at as it relates to technical insights and scientific insights for any future policy.
And I'm just going to jump in here quickly and ask a question, Brett, before we go to the second part. Finland was not in that meeting in April 2019. What is the omission there, since they're the first ones in the world actually constructing a deep geological repository?
Well, and as you somewhat heard, is the board engages the international community. The last time the board visited Finland was 2002, and we really have not had much contact with the Finns. We had planned to, and you'll see in the second part of the presentation, we have more recent conversations with them, but the board was familiar with the Swiss, the French, and the Swedish repository programs. And that was the direction that I got as a staff member to reach out to those. They had visited the URLs already and were familiar. And the presentations were more about how those URLs are being used in terms of the policy. But I will touch upon the underground research labs in Finland in the second part of my presentation.
Great, thank you. And I know that there are a number of questions out there, also a number of hands raised. So hold on to them and we will get to you all in after part 2. Over to you again, Brett. Thank you.
Okay. And I've changed backgrounds, and there's a reason for that. The background is Yucca Mountain, and a key point to take away from the second part is that laws of nations define what the repository program is. And as I stated in the first part, in 1987, Congress redirected the program to focus on Yucca Mountain. And I will address Yucca Mountain in the second part. Hold on a second. Need to share the screen. And away we go. So importantly, this is my own analysis. It does not represent the views of the technical NWTRB, and you can see a little bit about what our charge is. But basically, what I'm presenting has really kind of grown out of feedback on the board's URL report from briefing of federal agencies, presentations like this one today, and discussions I've had at conferences where we've presented the report and have had the opportunity to talk to other people associated, like Finland, Sweden, with different people to kind of get at a comment that was made in the closing session of the workshop, which was made by an implementer. And the implementer said this, and it struck me. An implementer will do whatever is required by the law and by the regulations that are implemented by the regulator, for instance, the Nuclear Regulatory Commission. If the regulation only requires a probabilistic performance assessment in a license application, then that's what the implementer will provide. So that made me ask the question, so what do other countries require in their programs, and what kind of decisions, and what's the timeline for these decisions? Another aspect, as the board developed the report on underground research labs, and I touched upon safety case before, they thought, the board members thought it might be a topic that we could explore either in a meeting with DOE, because as you heard earlier, DOE does use this concept of important to safety case as a way to direct their R&D program. But we look at the literature, we talk to people, and so this analysis is based upon my gathering of knowledge since January on the idea of the safety case. So let me talk a little bit about this. This looks like a very dry outline, and it is, but we'll get there. I want to talk about the safety case some more, the use of underground research facilities, either R&D like DOE is doing now, or research development and demonstration like all the other countries do. I also want to go back and revisit that thermometer and talk about technology readiness assessments and technology readiness levels. What may not be clear with this outline is where I hope to lead you. My analysis will compare and contrast four national approaches to these topics. It will address the application of the safety case concept, use of URLs, and technology readiness at the time of a license application for repository construction in Finland, Sweden, France, and US under the national laws that govern each program. And in the case of the US, I will provide some technical considerations, how these concepts could be applied if the nation continues this period of conducting generic disposal research and development activities, or if it decides to do something different than the Nuclear Waste Policy Act, or if it decides to restart the process under the current law. So with that as a teaser, let me jump into the safety case. One thing to realize is the Nuclear Waste Policy Act was developed and made law before the concept, the safety case concept was really developed. And this concept really began to take hold in the 1990s, and the OECD, Organization of European Commission, whatever the last D is, the Nuclear Energy Agency's group there developed the integration group for the safety case. This was formed in 2000, and on their website, basically, there's this nice little vignette of what a safety case. The safety of a repository is evaluated and documented as a safety case that supports a decision-making at each stage of repository development. And I'll talk about those stages, but again, I'll just remind you, selecting a site, requesting to be able to construct a repository, and also requesting and deciding on whether a repository can operate. So the safety case, again, is a process that gets bigger and broader as a national program progresses along that timeline. And so DOE's disposal R&D program is using the NEA definition, which is below. And again, it mimics, or it's close to what I said previously, the IAEA, International Atomic Energy Agency's definition is. But again, it becomes more comprehensive and rigorous as the program advances, and is a key input to decision-making at several steps in that repository program. So this is a complicated diagram. It's a diagram that DOE is using in its disposal R&D roadmap update, i.e. their reprioritization in 2019. It's focused solely on the disposal safety case. And I would point out that the safety case in other countries actually are broader than this. They will have a transportation safety case, they might have an environmental safety case, and they'll have a disposal safety case. And all of those things are explained to the public. And that's the example of the UK. The Netherlands, which doesn't even have a repository program, has developed their OPERA safety case, looking at where the waste is stored, transportation, and disposal options in the future. The key thing to take away from this, and I won't jump the gun, but basically DOE is focused on the post-closure. As I said, that's their R&D. So they're not dealing with site selection or pre-closure basis at this point. But the thing that underpins all countries, both safety case and their repository programs, are the national laws and the regulations and rules that implement those laws. And we'll come back to those later on when I start talking about the individual countries in particular. But again, laws and regulations control what gets done in terms of a safety case and what type of research is done at various points in the decision-making process. So, and I borrowed this from Harry Young from IAEA at the time he was developing a compendium of underground research laboratory results. And these are the chapter headings of how underground research labs are being used around the world. And you'll note that in the upper part are basic R&D type of activities. And down below are the demonstration types of activities. And it's almost a logical progression. Even before you get underground, people test their instrumentation and sampling and monitoring techniques before you go underground. Then you get underground and you start to look at the fundamental properties and behaviors of the rock, because each of the time steps you have to iterate on your research. And so it's a progression in time as you advance your technology, because your science understanding has become better. So next, I'm going to launch into how each of the countries use their underground research labs, with Finland, Sweden, and France. They start with the R&D, but they end up with the RD&D, and they end up there before the license application is submitted for construction authorization. I will also talk about the U.S. spent nuclear fuel and high-level waste-related programs. As we heard earlier in the first part of the talk, focusing on R&D, the post-2010 disposal R&D program. But I also want to bring back and come back to the Nuclear Waste Policy Act to hopefully provide you some insights why R&D was done at Yucca Mountain and not RD&D. So here's a timeline for Finland, and I think it's the most complete timeline I've seen. This is presented by Tina Halonen of Posiva earlier last month. And across the bottom are the decades as they go by. And here's the 100 years of operations, more or less, before they expect to close their repository. There's work done on the disposal concept before there's a site. In the case of Finland, they chose a site-specific underground research laboratory. In other words, they chose a research laboratory that would be part of the repository. And so the government decision in principle was down in 1992, and well, I should say the decision on disposal. And I think it was the early 2000s, yes, 2002, the decision in principle and the beginning of the construction of the Onkalo facility. In other words, this was a siting decision, and this is when they began to develop their underground repository. Onkalo is unique in the sense that it's a licensed nuclear facility, and it was a licensed facility from day one, which means both the implementer, Posiva, and the regulator, Stuk, could use it to develop their capabilities prior to the license application for construction authorization. And I'll step back here and tie it back to the Stimson's work on safeguards. Olli Oko in 2017 had a wonderful paper called The Safeguardability of Repositories. And Finland is really at the forefront of the safeguards issues. And what he pointed out was an important one, and something I had forgotten about, is that every country makes two decisions in a repository, fundamental decisions: a safety one, which I've been talking about ad nauseum all morning, and a security one, which is from the safeguards. And Ollie pointed out that you have to consider both when you're designing your repositories, not just for safety, it has to be safeguards as well. And if you're demonstrating the technology for safety, you should also be demonstrating the technology for safeguards. One important thing that I think that I hadn't realized until I was reading some of the background report is that Posiva is required to submit a triennial R&D plan. And again, this is in addition to any sort of decision-making documents. This pushes the program in an iterative fashion along from when we first begin to understand how the site and engineered barriers will work to when you apply for a construction authorization and further on. In the Onkalo, full-scale in-situ testing occurs after the receipt of the construction license. So let me move on to Sweden. Sweden has a long history of underground research labs. The Stripa mine, again, all of Sweden is in crystalline rock. The R&D was carried out for a good period of time. In 1986, as Sweden changed its laws and developed their process, excuse me, for the repository program, was approximately the same time that the Aspu Hard Rock Laboratory began. And you'll see, again, the chunks of time As you start to investigate the site, you construct it, you begin to operate it, and you can see all the way up to the present where they've done prototype repository in the canister retrieval test, which is full scale, non-radioactive, but it's the idea of demonstrating those technologies. All of the URLs in Sweden were not site specific. They were not licensed and did not use waste. And I should have said that the Onkalo in Finland also did not use waste. Similar to Finland, the implementer SKB triennially produces an RD&D program. I know a little bit more about the Swedish program and Swedish law, but basically that R&D program is reviewed by the regulator, and the regulator is required to provide some invited interested public comments as part of that review, and I think it might be an appendix or something. And that review by the regulator, invited interested publics, is provided to the government. It's also reviewed by the Swedish National Council and provided to the government. Swedish National Council is an organization that is comparable to the board in the US in that it's an independent advisory that reports directly to the government. And again, this RD&D program is produced in addition to decision documents such as a license application for construction. France, and I'm gonna try to scoot as fast as I can so we can keep some time for questions. 4 underground research laboratories, 2 still operating, the Tournemire Research Tunnel and Burr. It's important to note that the Tournemire facility is actually not run by the implementer. It's actually run by a technical support organization that is supporting the regulator. France's process, after the 1991 national law was passed, 3 sites were characterized and license applications. 4 underground research laboratories were submitted in 1999, and I think this was after the first public debate. The Burr site and URL began. It was developed by the implementer. Unlike Finland and Sweden, which is a consortium of the industry, ANDRA is a government agency. The URL is licensed until 2030 and does not use waste. And again, a staged long-term process in terms of assessing the disposal suitability concept, begin to provide the scientific basis for safety options and design construction, and even prototype high-level waste disposal cells. Again, the idea of demonstrating the technology. Unlike the others who have already submitted license applications, France is close to it. So right now they're optimizing their technical solutions before the disposal facility construction. And this last figure on France is to put into perspective the scope of these underground research lab. At the end of 2018, almost 1.8 kilometers of drift around these central shafts had been extended and drilled. And the last 2 stages that I just talked about on the previous slide are in the 2 different colors. And you can see this is an extremely active site with over 3 million data per day being collected. And I want to contrast, keep in mind this photo as we begin to talk about the US program and R&D as presented in the Nuclear Waste Policy Act, specifically for Yucca Mountain. So moving on to the US URLs for spent fuel and high level waste related programs. We'll first start with the Yucca Mountain repository program. DOE only undertook at the site R&D. And I think it's important to note what the act really is. And that comma in the middle of the second line is an important one, because in the act, Congress separated those 2 processes in 2 different titles. In Title I, which really was about the repository program, it was really focused on site characterization and of the potential site at Yucca Mountain once it was redefined in 1987. But a definition in the act is limited subsurface lateral excavations. Compare that to France with its 1.8 kilometers of lateral excavations and borings. Limited. And in situ tested needed to evaluate the suitability of the site, not the suitability of the disposal concept, but suitability of the site. Later in the same title is the site and approval and construction authorization requirements. And again, these are just snippets of the words in the law. At the time, the site recommendation is supposed to just have a description of the proposed repository, preliminary engineering specifications, and description of the waste form proposal. Moreover, the Nuclear Waste Policy Act required DOE, after the site recommendation was approved, shall submit an application for construction authorization not later than 90 days after the recommendation was effective. So the law basically said you're going to submit a license application on something that's not really technologically very far advanced if you're talking about preliminary engineering specifications. The second title, which is where R&D, Congress recognized it back in 1987, but they focused on the past experience in the US in which actual radioactive waste was used in an early underground research lab, and there were some problems. Of course, that waste was liquid. But Title II had some limited implementation, and that limited implementation concerned dry storage technology, which DOE implemented at the Idaho National Lab. But in terms of all the types of things that I talked about earlier, these other countries are doing in terms of demonstration, that was all in Title II. The term demonstration does not exist in Title I. Moreover, the Title II describes a specific type of facility, a test and evaluation facility. It means at depth, prototypic, underground cavity, substantial lateral excavations. I would say that's a URL. But it focused on including the development of data and experience for the safe handling. Each facility had to be capable of receiving waste. And importantly, those facilities had almost as rigorous siting criteria as the repository itself. So it was from my perspective only, it was a disincentive for the US to do any RD&D that could support a repository that was going to be cited and recommended, cited, and potentially constructed under Title I of the Nuclear Waste Policy Act. So now let's switch to DOE's current R&D program, the post-2010 disposal R&D program. And this is a figure that David Savugian put into that report along with his national colleagues or national lab colleagues that identifies where they are. Right now, they're in the whoops, sorry about that. They're in the generic repository R&D phase over here. And so they are very low in terms of technology readiness level. And they depict, the DOE depicts that it's a linear progression, which is a little bit different than the other countries because other countries are moving their disposal concept along as the siting process is going on, because you can't really have good siting criteria if you really don't understand the design for what a repository would be in salt. So another aspect is that for what's happening now is the activities that DOE is conducting is not really under the Nuclear Waste Policy Act, but DOE appears to be following what are their own orders, which describe in this order, DOE 41313B, which defines certain expectations of technology development as decisions go on. So I would argue that this alternative section, if DOE is trying to make that decision on whether dual purpose canisters can be directly disposed, DOE should be up at a TR level 4 rather than TR level 1, where their basic TR level 1 is it possible? Is it feasible? Whereas TRL 4 is much more advanced. So now let's go back to that thermometer and talk about technology readiness for the programs. In the middle column is a fancier diagram with larger letters on that NASA technology readiness level approach. And as I said earlier, Sweden was at a TR level 7. Basically, they've system prototype demonstration in the underground environment at the time of their license application for repository construction. Tina from POSIVA, again, back in March, presented a new slide, first time I'd seen this slide, where she indicated and mapped the POSIVA program relative to the NASA readiness scale. And what she said is at the time of license application, for repository construction, they were basically at TR level 6. They had done subsystem scale tests in Oncolo. And as I said earlier, they're doing their full scale testing, the FST test, now that they have a license application to construct. So now let's get back to this idea of underground research labs, their ability to advance technology in societies and bring the society along in repository programs. Main point, every program will have to be at a level 9 to operate its repository program. And every program will go through each level during its development. But a key thing that each country should decide is what level a program should be at each key decision-making point. Site selection, application for construction, or application for operation. Those laws define, and the implementing regulations define, the expectations of the country as to where they are and how much more work needs to be done. Let me explain that in 2 examples here. So at the time of license application, let me do the first one. This is Sweden. So at the time of construction authorization, the amount of technology development is relatively minor, going up from 7 to 9. So you can imagine that it might be 5, maybe 10 years at most before they could be operating a facility. And I can't see what I just did. Yes, okay. The second example is of a country that is much further behind. Like at the time of the license for repository construction, maybe you only have preliminary designs and you haven't even developed the technology. What it means is that if you are approved for a repository, to construct that repository, there's a huge amount of work to get you to the next step, which is an application for operations. So let's bring it back to decision makers and what this means. And so I have to think about this for a second. So if the decision makers in the US choose to go back to Yucca Mountain, they and everyone else who's interested in the US program should understand that there's going to be a tremendous amount of effort to increase the technology to get to a point where a facility at Yucca Mountain could operate. And that's assuming that it was approved. I'm not saying prejudging that. I'm just saying that from where DOE is on the Yucca Mountain license application, it will take a lot of effort to get there. Alternatively, if US decision makers choose to go a different path and get rid of the Nuclear Waste Policy Act, I would argue that this construct of thinking about underground research labs that are not using radioactive waste but are demonstrating technology, some sort of intermediate steps in terms of like a triennial R&D plan to push along the program and make measurable progress until you get to those key decision points, has helped other countries both from a technical and social aspect. And finally, if decision makers choose not to do either one, but continue the generic repository program, I believe one of the considerations is at what level DOE should be in terms of making its decisions on whether to move forward with, potentially move it forward with the direct disposal dual purpose canisters. So in conclusion, I hope today I've showed that underground research laboratories play a critical role throughout the world, that the safety case for a repository and technology readiness of a repository can be advanced through these URLs, and the development of the safety case, use of our URL, and how far you are along on that technology thermometer is determined by the laws and regulations that govern geologic disposal in each country. And I really want to thank the Stimson Center for offering me this opportunity to present this information today, because I'm counting on those questions in the recording to make my thinking sharper or to challenge me. And Cindy, thank you for hosting today, and Tran also for being my moderator. I've really enjoyed it, and I look forward to the next round of questions.
Thank you, and it's our pleasure, Brett.
Yeah, thank you so much for a great presentation, Brett. So we already received a lot of questions from the audience. So let me take a question from the one who raised their hand. So Bob Hostek. Hi, Bob.
Bob's muted. Oh, there he is.
Yeah.
Hello, am I on now?
Yes, you are.
Okay, so a major new issue, which you were just talking about, Brett, was the increasing concern about the near field thermal loading from larger canisters and increasingly higher burnout fuel, and addressing that in the URLs. And my question is, isn't there just a simpler way to deal with that, like 50 to 100 years of pre-emplacement cooling to reduce the thermal loading, particularly as the fission products decay in that first 100 years?
Yeah, and that is actually one option that Sandia National Lab looked at when, back in the early 2010. I think the Ernie Harden presentation. That yeah, you could for an argillite repository, that storage time might be 100 years. So again, you're advancing your program for a very long period of time rather than and really leaving the decision up to future generations in terms of doing that. But yeah, that is one option. Just store the waste for a longer period of time. It will get cooler with time.
And this was a major finding coming out of the 20 years of operation of the Canadian URL at Pinawa, which I highly recommend you go back. I'm going to send you some of the documents that they do go back to before your time, Brett, but there was a 20-year series of experiments that actually resulted in a large multi-volume environmental impact statement, which is the basis for the Canadian program for granite disposal. And so often, people are reinventing a wheel, and there's a great wheel out there that's fully documented. And the concern in Wisconsin was that the findings from the Lac du Bonnet granite were directly transferable to the Red River phase of the Wolf River batholith in Wisconsin, and that was a major concern that Yucca Mountain would fail and that the first U.S. repository would be in Wisconsin based on the findings of the Canadian URL. So there's a very interesting story there. I'll be happy to share it with you.
Thank you, Bob. I appreciate it. We'll follow up offline, okay? So we can get some more speakers or questioners in here. Trin, you're muted.
I forgot to unmute myself. So we have a next question coming from Liang Yang.
Hello, Liang. Are you there?
Hi, Liang.
Oh, can you hear me?
Yes, I can. Thank you.
Okay,
very much.
I just mute. Yeah, okay. So what is NWTRB's assessment in terms of TRLs for Yucca Mountain? What's your assessment for disposal DPCs?
So one, first, the board hasn't even addressed the TRLs. The second part of the presentation was my own. I would say, and this is my own personal experience based upon like the quarter scale tests that were done at the Losi Road facility in Las Vegas, probably for Yucca Mountain, maybe TRL 3 or 4. But again, this is a concept that I hadn't even thought about when I was in the Yucca Mountain program at the Nuclear Regulatory Commission. I would say for the direct disposal, as David Savugian points out, DOE is doing generic studies, and they're down at TRL level 1, basically. Is it feasible? Whether that's okay or not, and whether the board would address that or not, that's up to the board members. Again, today, second part was just me looking at things.
Yeah, I understand that whether we will reopen Yucca Mountain has a lot of factors to consider. But just in terms of your TRLs, are we thinking that if we reopen Yucca Mountain, basically we shorten the time needed to get us ready for repository side, because the TRL for Yucca Mountain is already like a 3 or 4.
Yeah, I don't want to talk about the licensing or how it's going. I put this is preliminary thinking, and I haven't thought about it. It's just the idea that if you're at a level 7, you don't have much further to go. If you're further down, you'll have a longer distance, and if you're starting from the very beginning, you'll have the farthest distance to advance on that.
Okay, thank you.
All right, so we'll take some questions from the Q&A box. Karen Stevenson asking, are some kinds of rock better than other for direct disposing of spent fuel waste storage packages?
Well, I wish all my former colleagues at the board staff would stop asking me these great questions. Yes, I'm glad for the question. There's no one best rock. They have different characteristics. So, for example, salt has a much higher thermal conductivity than argillite, which means it's much easier to put in a hotter package because the heat dissipates rapidly away, or more rapidly away from where the emplaced waste is. But you have to balance that with the mechanical stability of the salt. And so there are very different aspects. You can't just say this rock is better than another rock. You have to put them all together with the design. As Sweden and Finland had the great position to only have one rock type. And for them, it was trying to find the less fractured rock in Sweden, and that's what they did.
Okay, thank you, Brett. We'll take one more question from Lindsay Craw. So internationally, as led in Sweden and Finland, the URL reached EU to support the repository safety key required by regulator. Does the US have similar regulatory approach that would deem useful the generic understanding gleaned from the URL study?
Yeah, so I think I addressed this, but let me clarify it a little bit more. Title I, which covers the repository program, does not invoke underground research labs. It invokes R&D relative to the suitability of a site, not the suitability of the disposal concept. And I think that, again, should the US decision makers decide or choose to go a different path, that is something that I think from a technical standpoint, other countries have clearly shown how important these URLs are in developing the concept in the repository program and informing the public so that there's more likelihood of the public understanding of the potential program.
Okay. So another question coming from Abdullah Kakshal. India and Pakistan are two nuclear power in South Asia. In light of expanding nuclear power in industry in both the country, safety of nuclear waste become all the more pivotal. Do you think waste management will become a common challenge for both countries given their geographical proximity and limited area for waste disposal? Thank you.
I'm going to try to answer this a little differently since when I worked at when I participated in the IAEA technical meeting on underground research labs, I was happy to be joined by colleagues, nuclear waste colleagues from both Pakistan and India. And India has had an underground research laboratory and for quite some time, and I can't remember how long, but they are looking at some of the issues that the country would face as they move forward. But I don't have enough background or knowledge about either of those countries to talk about their waste management system. So I'm sorry.
Thank you, Brad. So Jennifer McBee asking about the public response to the where the sites are, especially in Bulle, France.
So yeah, these are large facilities and there's a substantial number of employees, and like all major projects that have a large economic impact, those in general, those communities surrounding it are generally supportive because it's a source of income. When we visited France, we had heard that there were some people that weren't happy with the URL and the potential repository at near Bulle, But again, I think France does a very good job, especially on the demonstration of the technologies that would be in that concept in their, excuse me, from the above ground aspects.
Thank you, Brad. So we take another question from April Palowski. Are there U.S. policy and regulation that prohibit the development of the site selection with consideration of disposal of waste? Why can't this be done in conjunction as learned from the Finland RD&D effort?
Well, that is a question that is not is best asked of the people in Congress and the administration if they want to pursue a different policy. Again, one of the points I want to make is if the U.S. intends to dispose of dual-purpose canisters directly, they can't just take the safety case and engineering design that Finland and Sweden are using off the shelf. They'll have to adjust it. They'll have to define what those safety functions are. They'll have to test those. You know, so a clear example is we know that the bentonite, the clay minerals in there, can degrade to something that doesn't swell. So the whole idea of a clay is it swells when it wets, and so it seals the waste from the fractured rock that could have fast transport or fast flow in fractures. Well, if you heat that bentonite too hot, maybe you degrade the chemistry of the mineral such that it can't swell. And so you would have cracks in the clay instead of a plastic type of material.
Thank you, Brad. So another question coming from Tom Pick. What is the range of the URL annual operating costs for the different country review?
I have no clue. I don't think I don't know, and I don't think the board discussed how much that is, but that's something that certainly in my thinking, I'll figure that out. Good question. Thank you very much.
So at that time, because we have 6 minutes, if someone want to directly pose the question to the panelists, please raise your hands, and I will go with the rest of the question. But we may have time for 3 or 4 more minutes. Okay, so I would like to go next with the question from Timothy. Oops, I just see Timothy Makatin, who just raised the hand. Hi, Tim. Can you unmute yourself and pose the question? Okay.
Right. Just a question. I understand your interpretation of Title I and what limited means. My understanding, which may be incorrect, but the limited was more directed to not allow DOE to proceed with construction of a repository before they got authorization from the NRC, and was not intended to limit what the DOE might do to get the necessary information to support a construction authorization. And I think based on what you said, I am going to go back to some of the committee reports to see what the intent, but my intent, I do not believe they were intending to restrict what DOE might do or considered necessary, but just a different perspective. Thanks.
As always, Tim, I appreciate your perspective. And I don't know if it restricted, but certainly that's the impact that it had on DOE. And I'm not judging or saying that it's wrong, but that's what happened in terms of relative to other countries. And again, you have to think back that the U.S. was one of the first out of the gun with its law, and couldn't take into account certain other things that people were learning along the way.
Right, but when they did do the underground laboratory, they didn't, they weren't restricted from doing that in any way.
No, they weren't, but they didn't do any sort of demonstration. And I think that, demonstration is not talked about in Title I. It's only talked about in Title II. And even if you look at the National Labs Lessons Learned report in 2011, which is Rob Burchard et al., they again talk about what could happen in the future. And again, they focus on demonstration with active material or radioactive waste. And I think that would be something that I think is problematic in the sense of allowing or encouraging the Department of Energy to develop the technology to support disposal concepts.
Yeah, I guess. So some of it's relative. I mean, the rail system for emplacement of waste.
Tim, I'm going to jump in here because
Okay.
I don't want to have a back and forth between you two. I'd like you to carry that on. There's one last question we'd like to do, and then so we can end maybe just 2 minutes later.
All right. Yeah, so the question from Mark Goodman. You mentioned safeguards several times, but not in your presentation. What would the repository safeguard R&D program look like? How is it different from the repository safety R&D program? How is it different from other safeguard R&D?
That's a topic, a complete topic, and probably Cindy has a better answer for that. But I would say that the best description that I found is in Mick Apted's 2017 book, and there's a chapter by Oli Oko, who's from from Stuke, who talked about the safeguardability of a repository, and that's by far the best description that I've seen. And I'm not a safeguards expert, so I don't want to go any further than that.
Well, I'll just pull that thread then very quickly, and we can end on a safeguards note, which is also that there's still a lot of work being done because Finland is leading the way, and each of these repositories are going to be unique to each country, not just in terms of the rock, but in terms of their own legislations, of course, and even their safeguards agreements with the IAEA. So there's still a lot of work going on, as I understand, between the IAEA and Stuke and POSIVA. There is more momentum now because there is actually going to be emplacement in the next 3, 4, 5 years. So that certainly is having an impetus. But in terms of if that approach is going to work for every DGR, that of course will have to be going along the line. And on that note, I just wanted to say, Brett, thank you so much, and for catapulting us to Yucca Mountain behind you, as well as you've been talking, and to the participants who have mainly stuck through the hour and a half, which is a wonderful testament also to the NWTRB's report and how much interest there is globally on this. And we'd like to have more conversations with the NWTRB as we move forward, and also hope to do more of these in the future. So thank you, Brett, thank you, Trin, and thank you to our participants.
And if I could add one final thing, for those of you who didn't get their questions answered or want to carry it on further, you now have my email, because the Stimson Center will be posting this presentation. It's listed on the first page.
That's right. Thank you for reminding me that you will be able to, this will be posted on our website, so feel free, of course, to forward it on, and we will also send this out in an email, I'm sure, at some point. I'll double check that. Thank you again, and stay healthy and housebound.
Thank you, everyone. Thank you, Brett. Thank you, Cindy.
Bye-bye.